Okay, hello, good evening, class. Today is the 24th day of November 2017, and I'm reaching you from Paris. Paris, I came here on a UNESCO mission, and we are going to take on circuit theory today. Uh, Solomon is coming on first, and it's my pleasure to invite Solomon to make his presentation in the next 8 minutes. Solomon, you have the floor.
Thank you, sir.
Thank
Good
you.
evening, class. Good evening, Saba. Yes, I want to talk about the recent development in circuit theory. Okay? But I want to start by looking at what is circuit theory. Circuit theory is an electronic device such as diodes.
Hold on. hold on. You are talking about circuit theory, and you are saying circuit theory is an electronic device. How do those connect?
Sorry, sir. I'm so sorry about that. I'm just trying to establish here that in circuit theory, we have electronic devices just like diodes and transistors, which act as valves or switches that are meant to control the flow of electric current. And because of the fact that they have high sensitivity and speed of operation. Now, the word circuit theory, we seen it to be the mathematical study of circuits that contain electronic devices. This is my slide 2, I'm going to slide 3. The main objective is that circuit theory is to provide a basis for which design of electronic and electrical devices can be assembled and connected together in order to perform desirable functions or operations on electrical signals. My slide 4. We also know that circuit theory also deals with models. And in this case, when we say models, we are referring to idealized abstraction that estimate the behaviors of physical systems. There are 3 phases of circuit theory. These include the development of suitable circuit models for electronic devices. Number 2, the development of analysis methods applicable to electronic circuits. And number 3 is accumulation of stored ideas from working with models and analyzing circuits. Slide number 5. The recent development in circuit theory is as a result of rapid technological and scientific advancement in the development of complex systems. And some of these developments, we have automation control, pattern recognition, data processing, communication. Let me go through them one after the other. In automation control, today we have systems all over the places, both in our cars, both in our workplace, where some machine does work with just and instead of giving instruction, you don't have to be bothered. You, the operator, or the person that is supervising that machine, the machine does work. And this is the recent development or part of the development that has occurred in circuit theory. They are now, because of that, what I said earlier about high sensitivity to operation, and systems are able to do good some jobs that human beings ought to be doing without all bothering, but we are seeing results. Now, pattern control and the pattern recognition. This is where we talk about machine learning and artificial intelligence in artificial neural networks, where the machine learn patterns and use them to do further operations. Now, data processing. Today, computers are not only used in just typing. There are a lot of works that we use computer to do. And this is with the help of these circuits that are being built to perform operations going on. So our networking, telephone calls, everything is coming down because the circuits are now there is a great advancement in the development of circuits that are more sensitive to operations and to ease the human intervention. Then we also have machine computation. We have, I've mentioned, artificial intelligence and neural networks. We have econometrics. There are circuits that assist experts in these areas to be able to fulfill their obligations in good time, both in operational research, multi-conductor transmission lines. This one has to do with the ability of this circuit to reduce noise to the barest minimum. Before now, when you start up a system like my system now,
you have 2 more minutes.
Okay, thank you, sir. You hear noise when the system is going on. But today, because of this improvement in development, we no longer feel the news. Then we have low power CMOS radios, CCTV, laser technology, and handheld devices that we are using today. I'm going to my slide 7, which is my reference. And this is where my presentation ends.
Okay, thank you very much, Solomon. Let's take some questions for him, and I'm going to ask Bidei. Bidei, do you have questions for him?
Yes, well done, Mr. Abam, for that presentation.
Yeah.
My question is straight to slide 4. I just want you to expatiate on the models in relation to the circuit theory.
Bidei, can you call that word? Hold on. There is no N in that word at all. It's not expatiate, it's expatiate. Can you say that, please?
Expatiate.
There's no N there. There's no N. So it's not expatiate, it's expatiate. No. Say that clearly again.
Expatiate.
My friend, there is no N in that word. So you can't say expatiate. Take off the N and call it.
Expatiate.
Oh, it will be difficult to get you out of that mode. Expatiate. There's no N. It's not expand. Expatiate.
Expatiate.
Go ahead.
Expatiate. Expatiate.
Enough.
Expatiate.
Enough.
Okay, sir.
Yes. Go ahead. Ask your question. Ask you to expatiate on what?
Expatiate on the models relating to the topic, sir. Thank you, Mr.
Thank you. Busayo.
Okay, thank you, Mr. Abam, for that present. I just wanted to ask you, are there any law that actually support circuit theory?
Okay. Jeremiah. So we can't hear Jeremiah well. Solomon, provide some answers.
For the question asked by Mr. Beley, I believe for us to have a durable design, we must first and foremost model some of these characteristics that I mentioned. And there are a lot of modern that goes in line with what I just said. The concept of modeling emphasizes on making approximations as part of the process of analyzing a physical problem. So for us to have a durable working circuit, first and foremost, we have to model it. When we model it, it gives us the opportunity to know how effective it's going to really solve that problem that we are targeting to solve. So that's exactly what I mean by that. Have I answered your question?
No, just go on. What about Busayo's question?
Okay. For Mr. Busayo, Apolabi, yes, there are laws. We have 2 types of laws. We have the Kirchhoff's law, Kirchhoff current law, and we have the Kirchhoff voltage law. Then we also have Ohm's law. These laws give us a guide
All right. Thank you very much. Let's take on Busayo. Busayo, let's look for your file. I think it's this one.
12,
No,
12 p.m.
yeah, that's fine. I'm just loading it now. Okay. No, this not Busayo. This is Bilei. Okay, I'm coming. Let me get your file. When did you say you sent it?
12 p.m. 12 p.m.
Okay, let's look for it. 12 p.m.
Yes, sir.
Yeah, that's earlier in the day. Yeah, here we go. 12 p.m. Right, Busayo, take the floor for 8 minutes.
Okay, sir. Thank you, sir.
Thank you.
I will be talking on the recent development in circuit theory. Now, on my slide 2, what is circuit theory? Now, circuit theory is actually a technique which is actually used to describe the flow of energy around an electric loop. Now, on my slide 3, now, when we talk about circuits, any circuit can actually be made from 2 components. We have the active component and the passive component.
Sorry again. You know, when you say a theory of relativity, circuit theory is a theory. Solomon started on a very bad note. He said the circuit theory is a device. You can see very clearly here that circuit theory is a simple process used to explain the flow of energy around a circuit, and you are coming up with a different thing entirely. So please start all over again. What is circuit theory?
Okay. Circuit theory is a technique.
Not a technique.
That is actually,
a theory is not a technique.
Okay.
You've written.
Okay,
Look,
sir.
I'm reading even your slide here. You can't say a theory is a technique. It's not a technique. Read what you have on the slide,
A
please.
circuit theory is a simple process. A circuit theory is a simple process used to explain the flow of energy around the circuit.
As simple as that. Yeah, please go on.
Thank you, sir. So, circuit theory is actually a process, a simple process that is actually used to describe the flow of energy around the circuit. Now, on my slide 3, I said a circuit can be composed of 2 components. Namely, you have the active component and the passive component. Now, when we talk about the active component, we are actually talking about the component that gives off energy. For instance, your battery, your transistors, your diode, your transformers, they are under active components. Then the passive component, they make use of energy. They needed energy for their own operation. For instance, you have the capacitors, the resistors, the inductors. They are all examples of passive components. Now, on my slide 4, now the cornerstone of any circuit depend on the following laws. We have Ohm's law and the Kirchhoff's law. Now, these 2 laws are used to express the relationship between current, voltage, and resistance. Anyway, now my next slide, that is slide 5, where I have the recent development in circuit theory. Now, permit me to say that circuit is actually a practical medium for transporting electrical energy. For instance, we know that electrical appliances rely on most of this energy for their own operation. And also, apart from that, circuit transports electrical energy which are actually needed to charge most of our appliances like car batteries and so on and so forth. Now, let's just look at the recent development. Now, I said, circuit theory are now probably used in traffic planning and implementation. How? Now, when traffic engineers and transportation planners want to estimate the traffic volumes in a network of roadways, now the only option available to them is to apply what we call the traffic flow theory. Now, the traffic flow is the study of the movement of individual drivers and vehicles between 2 points and the interaction they make with one another. Now, the traffic flow theory is applied using the circuit theory, and this theory is actually rooted in the principle of conservation of energy, while for electrical theory it takes the form of Kirchhoff's law and the Ohm's law. Now, on my slide 6, cycles are also used in the manufacture of integrated circuits. Now, few decades ago, we all know that the computer used were huge in size, they were very big in size, but today they are compact in size with more capability and less maintenance. That's one area in which the circuit theory has actually been applied. Also, in my next slide, my slide 8. Now, circuit theory are also employed in the production of logic gates. Now, we all know that
sorry, Busayo, I've asked that you should take a look at your slides and avoid spelling and grammatical errors which you find all over the place. Circuit theory are.
Okay, sir.
What should it be? What verb should you use here?
Circuit is also employed.
Exactly.
Sorry, sir. Circuit is also employed in the production of logic gates, which are the building block gates in electronics. Now let's flash back to, I missed one slide. Let's flash back to slide 7. Circuit theory is used in the production of mobile charger. Now we all know that most of this mobile charger that we use today consist of capacitors. Most of them consist of the NOT inverter and the transformer. So there are this one area in which the circuit theory is being employed. Then lastly, on my slide 9, I have my references. Thank you.
Thank you very much. All right. So let's take on Solomon. Solomon.
Thank you very much for this presentation. I want to ask, in computing now, the use of this, what can we say about the use of a modem that we are using now?
You know, the man has just got a modem. Solomon has just got a modem. So, yes. Yes, go ahead.
In one of these laws that you just mentioned, now also Okebukola law, which of the law that this device is supporting?
Okay, Billy.
Yes, well done, Mr. Busayo. My question is on slide 3. You mentioned there the components of the circuit, active and passive. But your diagram, can you please denote which of them are passive units and which of them is active? Thank you.
Okay, let me. Okay,
No. Hold on. Jeremiah, are you active or passive?
Yes, I'm active, sir.
Okay.
Sorry.
Okay, good evening.
This active and passive that you have tried to identify, can you also refer to them as being the conductor and resistor?
Conductor and resistor.
Okay, yeah. So, Busayo, provide answers to the questions.
Okay, let me quickly respond to Mr. Bele's question. From there, you have the diode. The diode is under the active component. The transistors is under the active component. Your resistor, your inductor, capacitor, they are under the passive component. Then to Mr. Solomon.
I don't think that's the question he asked you. He saw those elements in the diagram. That's not what he asked you.
He was asking me that I should really point which one of them is active and passive components.
Sorry, Billy, is that your question? Because
Yes, sir.
but weren't you listening? That was what he said when he was making the presentation. Anyway, go on, Busayo.
Okay. Let me to Mr. Abam's question that what is the Kirchhoff law? Now let me just explain that when you talk about the Kirchhoff law, anyway, the Kirchhoff law is divided into two laws. We have the first law and the second law. The first law actually states that the total.
Sorry, Busayo. I'm so sorry. I'm sure one of your teachers will have told you how you mix up tenses, verbs, and all that. You know, laws. You should know which one is singular, which one is plural. When you say, you just keep going like that. I think you should make some conscious effort to try to assure that your plural noun matches a plural verb. You know, rather than just mix things up like that. But yeah, make some effort in that direction.
Okay. Thank you, sir. The Kirchhoff laws, they are divided into two. We have the first law and the second law. Now, the first law states that the total number of current entering a circuit must be equal to the total number of current that is actually leaving the circuit. Then why the second law states that the algebraic sum of all the current in that cycle must be equal to 0. That is the Kirchhoff law. Therefore, to Mr. Jeremiah's question, that can we actually refer to most of these components as conductor and resistor? I think I will just tell Jeremiah that you can really go deep. You can really Google them and check if they can actually classify.
No, just a minute, class. Did you hear Busaya just now? Did you hear him pronounce Google for the very first time correctly?
Yes, sir.
The man needs an award. That he didn't call it Google today. Yeah, go ahead.
Thank you, sir. So, Mr. Jerry, so you can Google them and check if Mr. Solomon, you said?
No, don't bother. So no. Solomon, you are conclude your response. Busayo.
Okay, so Mr. Jerry, you can Google more on this and check if they can actually be referred to as conductor and resistor. I'll also do mine also too. Thank you.
Wonderful. That's good. Smart. Very well. Beleyi, let's move on to you and tell us what the timestamp is on your
12:18 p.m.
12:18 p.m. I think that's the one I'm seeing right here. Yeah, that's it. Actually, 12:19. Is it 12:19? Okay. So, Beleyi, let's roll. We'll see your slides. You have the floor, Beleyi.
Good evening, class.
Good evening.
Good evening.
We're speaking on the topic recent development in circuit theory. So I move on to my next slide, which is the second slide, and I have my outlines there. So, we can see the outline. So I move over to the next slide, which is the third slide. That's my introduction. You see, basically I want to say this class wouldn't have hold if not for the knowledge that we have had, or the invention relating to circuit theory. So I move over to the next slide, which is slide 4, that is the definition of circuit theory. And I want to say that the theory is comprised of numbers of different laws, ideas, and definitions. These laws include the Ohm's law and the Kirchhoff's law, which the last presenter has really expatiated on. They describe the relationship.
Congratulations, Beleyi, for removing N from expatiate. You did well.
So these laws describe the relationship between current, voltage, which I also mentioned as on my next slide, which has to do with the basics in terms of electricity. So the laws, we can't do without them, and I really appreciate what the last speaker has said based on the relationships. Talking about that too, I also want to talk about the techniques, which may also refers to hydraulic or pneumatic circuit, which involves the flow, the fluid and gas relationship. In electrical circuit, is formed using numbers of components such as batteries, wires, capacitors, resistors, and switches. So on these slides, whereby you can also see lower the text, the authors of some of these components that I've mentioned, and the name you see there is Andre Ampere. Most of them use their names, and I believe that at the end of our course, some of us will be using our name to invest one of these things that will be of use in the near future.
No, Gwile, let me tell you how it happens. It's not that Ampere by himself will say you will call that unit Ampere. Not him by himself. It is the group of other scientists that will gather and say, okay, how do we recognize this man? And they will say, okay, let's name this unit amperes. So that's how it goes. It's not that whether you will wake up one day and say, okay, this unit of class it's going to be called Gwilei because you are the class captain. No, it doesn't work that way.
Okay, sir.
Yeah,
Noted,
yeah,
sir.
yeah.
So, to continue, I quickly want to ask the class, based on the knowledge and ideas that we have gotten for our distinguished professor, I don't know what name, if he's no longer with us, that we are going to give Professor Peter Okebukola. So, on my next slide,
Gwilei, you are not serious. But go ahead. You know, it's like a unit. You know, Kelvin,
we'll decide
Celsius.
on that, sir.
No. That's not how you decide. It's not the three of you or four of you.
What has been our contribution so far?
Go ahead, man.
Thank you, sir.
Yeah.
So my next slide also, you'll see George Simon Holmes and the year he invented this idea. Then to summarize the laws that has to do with Kirchhoff laws, the total current in parallels and that of the sum of all voltage drops. Now to the main job of the day, the recent development. I've listed some on these slides, but I would like to talk about that relating to the logic gate. Electronic logic gate differ significantly from their array and switches equivalents. They are much faster, consume much less power, and are much smaller. All these tanks goes to the circuit theory that we've been talking about. The semiconductors logic gate, on the other hand, act as either high gain voltage amplifier, which sink a tiny current as its input and produce a low impedance voltage at its high impedance. Then I also want to talk about one of the recent developments in circuit theorem that has to do with mobile devices. We know that most of these things are as a result of the development in circuit theory, which has made most of them smaller now, and we can see the genesis from the various logic gates, the various simple devices that we have now in terms of hand devices. A very good one is a simple AC batteries charger. Usually have much higher ripple current and higher ripple voltage than other kinds of battery because they are inexpensive designs and built as a result of this circuit theory. Then the last one which I want to talk about has to do with mirrors. I'm very sorry because I skip it from this slide that I sent. Mirrors is basically a fourth class of electric circuit theory, joining resistors and capacitors and inductors. They exhibit a unique property, primarily at a non-scale. And the benefit is simply that it retains more memory and data in power-off mode, which allows system for quick output. Then another benefit of this memoristic is that it uses less energy and produces less heat. So I can go on and on like that. Most of these devices, most of these recent developments are a result of circuit theory in general. And my next slide is about my references. Thank you for listening.
Good. Well done, Gwilei. I actually love your slides. They follow some nice pattern, some LASU pattern. And I like the images that it showed of ampere, volta, and all of them, and the connections. And then your last but one slide gave a listing of the devices where circuit theory finds a place. So very nice.
Thank you, sir.
Yeah. So questions, Solomon?
Thank you, sir. Mr. Pele, you have done great. You have done well. I want for you to.
You are not ready yet. You are just babbling.
For
Jeremiah.
to talk more about this spice camera. What is this spice camera?
Okay, hold on for him. Hold on for Solomon. No, hold on for Solomon. Yes, go ahead, Solomon.
I want Mr. Pele to speak or throw more light on this spy camera.
Oh, spy camera. Okay, that's fine. Okay, Jeremiah. Busayo.
Okay, thank you, sir. Thank you, Mr. Gwilei, for that presentation. You talked.
No. Jeremiah, you are not coming on. Jeremiah, sorry, we have finished with you. Busayo. Yeah.
Now you made mention of memory store. I just want to ask, this memory store, can we actually classify it as active component or passive component? This memory store that you made mention the last time. Can we
Okay.
classify it under active or passive?
Okay. Back to you, Jeremiah. If you are still active or passive or in between. Yes.
I am active, sir. I am active, sir.
Then you are not, because we ask a question. So, will I answer the two questions or observations that the other two people raised? Yes.
Yes, thank you, Mr. Abam. The first one that has to do with pixel camera is simply a development or one of the recent development that has to do with circuit theory. If you look at it from the initial point of view, most of these things are electronic based. So virtually all of them are built around logic, are built around everything that has to do with circuit theory. So definitely they cannot come into existence or they cannot be invented without the theories that we have mentioned or talked about. Then going to Mr. Busayo's topic, thank God that you gave us an explicit detail that has to do with active and passive theory. So the memory store is a passive. Thank you very much.
All right. So, well done, Willie. And let's see if Jeremiah, you are the anchor leg of this four-legged race. If you are set, are you set?
Yes, sir. I'm set, sir.
What's the timestamp on your file?
525, sir.
Is it 525 or 519?
519.
All right. Well, I'm seeing 519 here. Okay. So, you have a way with all these your dark colors. That's what you did the last time. You know, anyway, so long as you can say it. You have the floor, Jeremiah. Please carry on. Jeremiah, please carry on.
Thank you very much, sir. Thank you very much, sir. Good evening, my colleagues. The topic before me is recent developments in circuit theory. Now I quickly move to slide 4. So I'm just trying to see that information and communication technology wouldn't have been in place today if not because of this circuit theory that we want to talk about. Now let's start. What is a circuit? A circuit is a series of electrical components or devices connected together with the purpose of passing current or electrons through a medium. Then I quickly move to slide 6. Slide 6. We talked of components. What are the type of components that can pass through a circuit? We have the batteries, the bulb, the resistors, inductors, switches, and the rest of them like that. You can see the picture right the right hand side. So we quickly move to slide 7. So we're talking about circuits. What are the features? The first one is the current. The second one is the resistance. And the third one is the voltage. A current is the rate at which a charge flows in a circuit per second. This is measured with ampere. So the amount of charge that passes through a point in a time is referred to as a current. Now, how fast the current flows will determine the electrical energy that will be brought to the component in that particular time. I quickly move to slide 9 because of time. We want to talk about two types of current, the direct current and the alternating current. We see the direct current that moves in one direction, but the alternative current at some time, it can rapidly move at the other direction. Now, there are other laws. There are laws of current, which is stated by Ohm's law. So Ohm's law states that the current through a conductor or the current passed through a conductor between 2 points is directly proportional to. Now I quickly move to the potential, which is all called the voltage. Now, according to the picture I have right hand, you can see the potential difference one and you see the potential difference two. So difference in the number called potential between each side of component in a circuit is measured in volts. So the difference between them is what we refer to as a voltage, but it's popularly known as a potential difference. Now, what are the recent developments in circuit theory? I haven't looked at the introductory part. Now, what are the recent developments? Now, recent developments, I mean the devices that uses circuit theory. One of these is what is called memory store. Memory store. Memory store is a new device. It was actually developed in the year 2017, and I saw the article. They updated 17th of November 2017. So, memory store is a device that was developed that has electrical components that limits or regulates the flow of electrical current. Now, what does it do? It's a kind of storage device that is more like a ROM. It doesn't lose its contents. It's very effective when you store information on it. So that is one of the application of circuit theory, memory store. Another one is called the microstrip. The microstrip is a signal technology. It is used mostly in networking or in communication. So that is another application of circuit theory. Then the other one is the muscular stimulator. That some of it that has been used in the gymming center and the rest of it all. So it also has the application of the circuit theory, and that is the end of the presentation. I have the reference at the last slide.
Very well done, Jeremiah. We won't have missed this for anything. You approached it from an interesting angle. You broke down the concept of or the components of a circuit, and you tied them together, and then you looked at some recent developments. Interesting enough, the recent developments that Bileyi had, a very long list, are quite different from yours. So together we have that of Busayo and that of Solomon. Together we have something, a comprehensive whole in this class. So if I ask you what is circuit theory, you just go ahead and state that theory and expatiate on it a little by looking at the components of the circuit, how they are connected, and examples just like Jeremiah has indicated, which will be driven by direct current or by alternating current. And you look at these laws, the two laws, and then you look at the recent developments. We'll just pick maybe like 4 or 5 of what Bileyi and Jeremiah listed all together. So let's take questions for Jeremiah. Solomon?
Thank you, Mr. Jeremiah.
Thank you.
You did a human job.
He did a what?
Human job. That's our football term.
Go ahead.
You did a marvelous work.
Yes.
I want to say, with what all of us have contributed in this very presentation, what will be your take on the future of circuit theory? Maybe projecting from now to maybe the year 2020. What do you see happening in circuit theory development?
Okay, thank you. Busayo?
Sir, no question, sir.
No. Are you sure you are in this class?
Of course, sir.
No, you are not. Don't embarrass yourself. You know I'm recording this, so don't let me use some harsh language on you. Anyway, next time just watch out for that. Bileyi, what's the rule of the class?
You must contribute to the class.
Exactly. It's either that you are adding or you are observing or you are saying something. You can't just come like to my class and say, yeah, no question. So please, let's go back to you before you break that rule. Yes, Busayo.
Okay, sir. Thank you, Mr. Jerry, for that wonderful presentation. Like the other time, you said that I should give if conductor or resistor, if we can actually classify them as active or passive component. I want to ask you also, as regards to that conductor and resistor, is there any difference between this conductor and resistor?
That's primary school physics now. Okay, Gwele.
Thank you, Mr. Jeremiah. My question is on slide 15. Yes, muscular stimulator. Because of
Yes.
my interest in sports, please, is there any adverse effect using this?
All right,
Thank
wonderful.
you.
I didn't get that from Ile.
No, you're talking about muscular stimulator, and you showed the picture of somebody carrying some weight. You see, Gbeleyi is into sports. He is saying that if you use that muscular stimulator, is there some adverse effect now and after, or in a long while, to the person who is being stimulated, whose muscles are being stimulated by some device? Is that a question, Gbeleyi?
Yes, sir.
Very good.
Correct,
So,
sir.
yeah, that's fine. So, Jeremiah, can you provide some answers to these questions?
All right, thank you very much, sir. I'll start with the Mr. Sion's question where you asked the difference between the conductor and the resistor. Yes, I would say that a conductor actually assists the flow of electricity or permits electricity
That is the
or
word.
electricity
That is the
current
word.
or
By the
current
nature
pass
of,
through
yeah, exactly.
while a resistor. So while
Yes.
a resistor can be used to regulate the flow
Good.
of
Good.
electric current.
Excellent. Excellent.
So there are two different things.
Excellent.
Without that, the conductor can allow electricity to pass through it freely without obstruction, while the resistors can be placed in between circuits in order to regulate the flow of electricity.
Okay.
And I'll quickly move to Mr. Abile's question. You're looking at the effect of this muscular stimulator. Well, according to what the work I actually did on this, I have just been able to see the practical application of circuit theory in some of these electrons that we have. I have not really explored the act of maybe the effect is going to have on humans and the rest of it. But I know that this is major. This is one of the things that we used, or one of the application of circuit theory now in recent time.
All right.
So
Yeah, even if you have not used it,
then
can we hazard? Hold on. Can we hazard a guess as to whether or not that stimulator will have adverse effect on humans? Let me give you an example. There is a device called the pacemaker. You see, in the heart of a human, there's a natural object that will, when your heart is beating like that, boom, boom. Now, there's a rhythm, and it is paced. There's something natural that paces that rhythm. But in an event that you have some challenge with some electrical wiring in quotes in the heart, you can get a small implant. It's called a pacemaker, which is put in the heart. It's also derived from a circuit. It tries to regulate the way the heart, the rhythm of the heart, the electrical signals. So there is no the advantage that it has is that in lieu of the natural thing. Busayo, there's some disturbance coming from your end. in lieu of the natural thing, you now get this artificial to help you. And if you are walking through a magnetic, you will just assume that if you are walking through a magnetic environment with a pacemaker in your heart, there's likely to be a distortion because of the effect of magnetism on the circuit. So there is some allowance that is given to people who wear such devices. Although recent developments, even in pacemaker, will not allow the magnetic environment to be too harsh on the pacemaker. So back to the question that Billy asked, you carry some weight and you put in something to stimulate, to stimulate your muscles. Definitely, there will not be any immediate impact, but maybe over time, there could be some side effects there are side effects to anything at all. Even if have you had your dinner, Gwile?
Yes, sir.
Yeah, like I said, I'm reaching you from Paris. Paris, UNESCO Paris, rather very cold here, and I've also eaten some food. But even the food that you eat, you still have some side effects, from it. What did you eat, Gwile?
I had bread and dodo.
Bread and dodo. I've never had that thing in my life. I know bread and akara, but I don't know bread and dodo. Busayo, what did you eat this night?
Semovita, sir.
Yeah, Semovita. Let me even see. I ate some food in the restaurant. There's some nice rice, some nice vegetables. No, not for real. The vegetables and some fish called poisson in French. Yeah. Jerry, what did you eat this night? He has not eaten anything. That's why it's yeah. Solomon, what did you eat this night? That's why it's inactive.
I ate concrete, sir. Bread and
Bread and what?
beans.
Beans. Hey, that now bread and beans. That was not bad. you know, when we were growing up, when you get beans and put gari and mix it, they used to call it sokudale. Sokudale. Have you had that kind of thing? Have you had it, sokudale? That is something that
No,
prolongs your
sir.
life. It prolongs your life. Yeah. Anyway, we had to divert to this to answer the question that Bele you raised. Well, I think we should bring the class to a close and to thank you all. We are missing this lady now in class. Tell her that we are taking attendance, and that may affect our score on attendance. It's important for her to note
Sir,
that.
She called earlier, sir.
All she needs to do, she doesn't need to call nobody. All she needs to do, at least we have been exchanging messages on the chat window. All she needs to do is to put something on the chat window to indicate. You can see Engineer Jijola all the way from India. Although did you see the message from Engineer Jijola?
Yes, sir. We
Okay.
saw it.
Yeah, it says after midnight in India. He's not supposed to join our class. He's our guest lecturer. He was our guest lecturer for one class. He's going to be guest lecturer later. And he sent a message, and I replied him that I'm also from Paris, and all of in Paris. So what she needs to do is to put a message, and that goes for everybody in our class. If you are not going to be present in class, just put a message there, and we note that. So I wish you a fine weekend. I'll be returning to Nigeria, God willing, tomorrow night, and then we'll keep our class. When is our class? I thought we said Monday. Is it Sunday?
Sunday, sir.
Exactly, Sunday. I already shared this thing with you. I will be off to Addis Ababa in Ethiopia on Sunday. I'll be arriving there 9-10 p.m. That's like 8 o'clock our time. So what I think we could do is let's shift that class till about 9 p.m. Is that okay?
Okay, sir.
9
Yes,
p.m.
sir.
your time, so that it will give me time to travel from the airport to the hotel where I'll be staying. So, dear class, best wishes for the rest of the weekend, and bye from me.
Thank you very much,
Thank you
sir.
very
Enjoy the
much.
festival back now.
Bye bye. Thank you. Thank you.